All right, so here's a little video on graphing parabolas because she is definitely going to make you do this. And in the problem, she's going to ask you for all of the characteristics of a parabola. Okay, so the first thing she's going to do is she's going to give you a quadratic equation, and then she's going to ask you if it opens up or down. So I think you know this part. You just look at the coefficient of the x squared term, and since it's negative, that means that this parabola is going to open down. Okay, so that means that what's going to happen is the vertex is going to be its max point. So the vertex is a max if it opens down. Okay, so the next thing we're going to do is she's going to ask you to find the axis of symmetry. So the axis of symmetry is an imaginary vertical line that's always written in the form of x equals. And what it does is it cuts the parabola in half so that the left and the right of the parabola are exactly the same. If you think of something like a butterfly, if you cut a butterfly straight in half, up or down, theoretically, don't actually do that, the left and the right are going to be the same. It's the same with humans, right? The left side of us and the right side of us are the same. So that's the axis of symmetry. The formula for the axis of symmetry is just x equals negative b over 2a. And so if you go up to the quadratic, a is going to be the term in front of x squared, b is going to be the term in front of x, and c is going to be the term all by itself. So we would do negative 4 over 2 times negative 2, and that gives us negative 4 over negative 4, which is 1. So our axis of symmetry is x equals 1. So what you can do is you can go over to your graph and you can put this imaginary dotted vertical line that's going to cut your parabola in half. Okay? Once you have that, the next easiest thing to find is your vertex, because your vertex goes through your axis. No, I say that backwards every single time. The axis of symmetry goes through your vertex. So for example, if this is your vertex, your axis of symmetry literally goes through it. So your vertex is somewhere on this imaginary line. We have to find how high or low it is. So to do that, you need a y coordinate. Well, this is your x coordinate. So the vertex is 1 something. So what you're going to do is you're going to go up to your quadratic and you're going to plug in 1. So it would be f of 1 equals negative 2 times 1 squared plus 4 times 1 plus 6. So that's 1 squared is 1 times negative 2 is negative 2 plus 4 plus 6. So we would get, what is this, 2 plus 6, so 8. So your vertex is 1, 8. So we would go over to our graph on our axis of symmetry and then go up to 8, and then that's our vertex. Okay, so now she's probably going to want you to get the x and y intercepts. Okay, so your x-intercept, you can have more than one x-intercept. Okay, and that's probably what's going to happen on your problem, is that you're probably going to factor and get 2. You don't have to. You could get 1 or you can get none. I don't think you won't get any. Like, I don't think that's going to happen because I just don't think that's the kind of thing she's going to go for. So I don't think you're going to get 0 x-intercepts. Like I said, it is possible. But if your vertex is above the x-axis and the graph opens down, you have to get x-intercepts because it can't just stop when it gets to the x-axis, right? So like, for example, if like in this problem, there's no way to not cross the x-axis because parabolas don't just stop. You could get 1 x-intercept, but that would only happen if your vertex is on the x-axis, so like this. But like, I don't think that's going to happen either. I really think you're going to factor and you're going to get 2 x-intercepts, okay? So we'll deal with that in a minute. The y-intercept, you can only ever have 1. And the way to get the y-intercept is just to let x equal 0. So you go back to your original equation and you do y equals negative 2 times 0 squared plus 4 times 0 plus 6. And every single time, you're just going to get this third term. So your y-intercept is 6. So if you go up to your graph, your y-intercept is 6. Now, from that, you can actually get another point, because since you have your axis of symmetry, if you have this point here and you reflect that over your axis of symmetry, you get another point. So you have 3 points now. You're well on your way to graphing this parabola. So I got this point right here literally by reflecting the y-intercept over the axis of symmetry. And you can do that every single time. Okay? Now, to get your x-intercepts, you're going to let y, whoops, it's doing that thing again, y equals 0. Okay? So then if you go to your equation, you would get 0 equals negative 2x squared plus 4x plus 6. And every single time here, you're going to have to factor. Okay? So if we factor this, you should, so x-intercepts, just think factor. That's what's going to happen. Okay? I would factor out this negative 2 first. So that literally means divide every single term by negative 2. And just be careful if she has a leading negative like this, you have to make sure that you change all of these signs. So 4 divided by negative 2 is negative 2. And then 6 divided by negative 2 is negative 3. So you just have to be really careful if there's a negative that you change all of the signs on the inside of the parentheses. So now if we factor this again, so into 2 sets of parentheses, we get x and x, we get 3 and 1 minus plus. And so that means, and like this negative 2, you technically here, I don't want to confuse you, you would divide both sides by negative 2 to get rid of this, and that doesn't change anything. But if you wanted to divide both sides by negative 2 to get rid of that, you still get 0 equals x minus 3 times x plus 1. And so then you get x equals 3 is one of your x-intercepts, and x equals negative 1 is the other. Now, if she has you write these as ordered pairs, you would write 3, 0, because y 0, and negative 1, 0. And then if she has you write your y-intercept as an ordered pair, if you look, x is 0, so this would be 0, 6. Okay, so now I'm going to go up and I'm going to plot these 2 points. So I'm going to plot 3, 0, and I'm going to plot negative 1, 0. And that's really all you need to graph the parabola. So now just kind of like connect your points. And that's your parabola. Okay, so she's probably going to ask you the domain and range. The domain of any quadratic is always all real numbers. So it's always negative infinity to infinity, or all reals, every single time. Okay? The range, remember, you always go bottom up. Well, this thing is pointing down forever, so the range would be all the way down to negative infinity, and then this vertex is the max, right? We said that at the very beginning. So this parabola goes all the way up to 8 and then stops. Okay, so that should be all of the things that she'll probably ask you. But if you have any questions, let me know.